All right. Motors, pretty simple. Mechanical problems. What's mechanical about this motor? Bearing. Pretty much it. We've got some pretty rugged steel here. If you want to know, it's page 19 in your book. And I wrote this up as questions to be answered because this is stuff that I think that I would have liked to have had covered to understand better. So if you've got any questions about any of it, ask me about troubleshooting because we're just going to go through this pretty quick. Pretty much got two bearings, two ball bearings. So, not much can go wrong here except bearings mechanically. Every once in a while you get a broken rotor bar. And if you'll see in this stator, as we seen in the picture a while ago with that motor, those slots that copper goes down in. Well, this has got slots in it, as we talked about earlier, that aluminum is extruded in. This is just an extruded in this chunk of steel. That's what creates your chunk of iron. That's when your magnetic field creates, it just runs around. All right. Every once in a while, one of these rotor bars break, crack. That can give problems. But that's something rare. I've seen in 16 years I've been in business, 3 or 4 in my life that I've seen that actually have broken rotor bars. But it does happen, and you would think that there's nothing wrong with the motor. The motor will run fine, not under load. You run it idle, it'll run fine. The way to find them is to completely disassemble the motor, and actually you do it assemble, but you apply low voltage to it and begin rotating the armature or the rotor in it. And as it goes through every pole, as the rotor bar passes through the poles, you see an amp spike, so you know that you got a bad rotor bar. There is, you can do grouter tests and different things like that, but that's some different tests you can do for that. But as far as mechanically, a motor, pretty much, you got some bearings. Now as far as what you're driving, that's a whole other ballgame. It can get complex. So, physical condition. Let's talk about the physical condition. You take this motor right here and you cover it up with a piece of insulation and it's running, it's going to get hot. It's designed to dissipate the heat away from it. So physical conditions, make sure that everything's cooling. Totally enclosed fan-cooled motor. I'm sure you've seen it. We've seen that back on the diagram of the picture that we looked at of the AC motor, or even the single-phase motor. It's got a fan on the back. And most of you seen these. The fan shroud has vents on it. If you ever get them too close to something where it can't draw air, then you're cutting your airflow down. You're cutting your motor's cooling capability down. When you do that, you're shortening the life of your motor. So make sure that it gets plenty of air. It can get stopped up. Trash in it.
The right motor for the application.
What's that?
The right motor designed for the application.
Right. That's a lot, but you know, so much of the time, you call your local motor shop, you say, hey, I need a 5 horsepower 184T 1800 RPM motor, 230 460 volt. Well, is it going to be, is it going to be totally closed or open drip proof? You know. Well, I say open drip proof. And we're going to mount it out here in where it's going to be in dust like you wouldn't believe. Well, that's not going to work too good. I believe that's a totally enclosed, non-ventilated motor. Anyways, an open drip proof motor will have vents in them. You'll see them, you've probably seen them in the plants, but they've got vents in the side. A lot of times in the end, it's just a, we call it open drip proof. It means water. It's drip proof. And water can come down, and it's drip proof. If you get any kind of sideways or up or standing, it's going to get in it. Dust. dirt's the same way. It's just an open motor, but they do run lots cooler than a totally enclosed motor. These motors here run hot. Fan-cooled motors run hot. People tell me that, oh, well, my motor is hot. How hot is it? Well, I can't lay my hand on it. Well, you know, 120 degrees is hard to, you know, it's pretty hot to touch. A motor running 120 degrees don't bother me one bit. 150 don't bother me one bit, you know. Then you go to getting 180, you know. When you go to getting 180 to 200 degree external temperatures, you're probably getting up close to 300 internally. So when you hit 300 internally, you're going to start having probably insulation failure. Though it's rated at a lot higher than that, a lot of times what happens is it melts the grease out of your bearings and your bearings fail. Environment, you know, pick the right motor for the environment. You know, if you're calling to order something or you're replacing something, or you've got a motor that's sitting out in a bad, don't put an open motor in a bad environment. You know, I mean, if you have to, you have to. If it's all you got, it's all you got. You know, when production stops, somebody's bathroom could get full. In our industry, or in your own industry. But anyways, you know, it's just the environment, whatever is suited. Do the best you can to decide. Let whoever you know that you're buying a motor from, what the environment is, you know. If it needs to be totally enclosed, it needs to be totally enclosed. If it's open, open is much better than totally enclosed to me, because they run so much cooler. If it's where you can, but sometimes space limitations limit a lot of stuff. These engineers design stuff sometimes that is out of this world. I'm sure all of you all run into that. Electrical. Any questions on mechanical troubleshooting on motors? They're pretty simple. You walk up to it, if you can turn it, everything looks good, everything around it looks good, you know. It's pretty simple process as far as troubleshooting. Now, if you spin it and it's making a loud noise, do something about it. If you can. If you can. If you can't, you know, if you gotta run, you gotta run. Run until she blows. Then get a new one.
This is a dumb question maybe, but I mean, this motor here, I mean, if you had an application where you had, is it capable of going
vertical? Yes, yes. Most any motor you buy off the shelf can be mounted vertical or horizontal. You might not get hardly as long as life out of it because it's not designed to run vertical, but these motors are very capable. If you see them hanging on fans, you know, you might see this motor on an exhaust fan and you would see it hanging up, you know, vertical. It's not gonna hurt anything. I will might talk a little bit. Uh-oh, locked myself out. Types of bearings, you know. Everybody familiar with the types of bearings? Everybody know what that is? Taper roller bearing. A lot of people call them needle bearings. We call them taper roller bearings. It's a taper roller, sits in there, you got an outer race. I'm just going over the bearing types a little bit here in this mechanical section on the motor. Here is I'm going to get my hands greasy. An angular contact bearing. You see these a lot in pumps. If you'll notice, see how this race is thin on this side and thick on that side? Thick here, thin there. You'll see this in the vertical motor where that weight comes in and it pushes this wide inner ring on the inside against the wide inner ring on the back. And this motor, this bearing can sit here and turn.
So is that a tapered bearing in there now?
It's called an angular contact.
But it is tapered.
Some people will call them a thrust bearing. but it's called an angular contact ball bearing. Yes, it's just a ball bearing, but you'll see these a lot in your submersible pumps. Nearly all vertical motors on pumps have these in them.
That's in the top, right?
Yes, this will be in the top on the vertical motor where the pump, where the line shaft hangs. Now your submersibles, it'll be in the lower part of the pump because it's supporting this angular contact bearing is supporting the weight of that solid shaft with the impeller hanging on it. And then your top bearing, which is a just a ball bearing. See that? It just works as a guide. And then this one works as your load bearing on the bottom. And you'll see here's another double row. You'll see this in a lot of submersible pumps. Double row angular contact. I brought a big one here so y'all can see. But anyways, you'll see these. All it is a single row angular contact. This is a double row made in one. And the vertical motors that you just asked about, you'll see the two of these hanging up there. Why they don't use one, I don't know, but they use two of these. Some manufacturers, some engineers design, I guess. But anyway, you'll see a lot of these in the lower end of pumps, double row angular contacts.
Ours, like your motor bearings, we talked about grease a little bit ago. What
Yes.
type of grease you recommend?
Anything with a polyurea base. We use Polyrex EM, which is a mobile product. A lot of people grab up anything in the world. Some greases are conductive.
What was the name of that again?
It's mobile Polyrex EM, but anything with a polyurea base. And I'd have to get a dictionary to spell it. I'm gonna grab a rag back here real quick. Lubrication on these, I guess we can cover that a little bit on mechanical. Lubrication is they're greases you don't want to, if you're already using grease, you don't want to change in mid-strike. When you do a change. You know, because what the lubricant manufacturers will tell you, you've got to get all the old grease out before you put new in. When we repair a motor, or all bearings that we sell that goes in a motor comes pre-lubed with polyurea-based grease. Now, submersible pumps, a lot of your pumps, these run in oil, so they don't have to have grease. So we ain't got to worry about it. Now I've got Greg. I know Greg's got some pumps that's not oil-filled motor housings that you have to grease. I mean, he can't grease them. They come pre-greased for life. And that's about a year and a half or 2 years. On those?
Yeah.
But anyways, any more questions on bearing types? And any of y'all, if y'all want to come up and look at these, or I'll pass them around, y'all can pass them around through class and look at them. I'm sure all of you have seen them. If you ain't, and you want to see them, you want to handle them, you want me to pass them around, you're going to get your hands dirty. You want to see them? What?
Is there any harm that you can do to bear grease it while it's running?
Do what?
due to a bearing by grease might be while it's running? We were told that you don't want to do it while it's on the run.
I do it all the time in the shop. That way I know the grease is getting circulated in there. That's me. Now, I've never heard anything other. Is it safe? They probably would consider it not safe. But as far as I'm concerned, let me tell y'all a little bit about something I've done about a year ago over here at CEA, Capeland Environmental. I don't know if any of y'all know those guys over there, but they have a 150 horsepower motor on the blower, and we repaired that. They've had all sorts of trouble, even under warranty with this motor. It's on a blower, and this blower, they have all sorts of problems with this system. Anyway, so they finally, the motor failed, and they sent it into the shop, and we rewound it. We sent it back, and the bearing temperature was running hot. And it's tripping out because it's got RTDs, which is a temperature reading on the bearings. And it's communicating with the PLC saying bearing temperature gets too hot, it shuts it down. And of course, and I'm going to tell you, my automation knowledge is limited. I don't know much about when it comes to automation. But anyways, I have to try to figure out what's causing this. So we go over and we start taking some temperature readings of the motor set beside it and this one. And this particular bearing is running 20 degrees hot. Is where we're at. We'll say it's running 180, the other one's running 160. I said, I told him, I said, let's try something. I said, give me your grease gun. And I started pumping grease in this bearing, and I pumped 10 shots. It was a roller bearing. It's a belt-driven application, so it has a roller bearing, which takes a lot more grease. I didn't bring one of those with me. But it's for a belt load. Anytime you see a belt load, you should have on a larger motor, you should have a roller bearing on the drive end. But anyways, I started pumping some grease in there, and I mean this temperature went up 20 degrees in 5 minutes. Just by that little bit of 10 shots of grease that I put in this bearing. I mean, it was unreal. But we did determine that this was bad on the motor. The RTD was bad, giving it a false reading. So we replaced the RTD, and I think the problem went away.